Bright QT. Every student matters.
Hello students, my name is Sanjay Jain. In today's lecture we will talk about quadratic equations. Till now I think you are comfortable with the concept of polynomials, and in polynomials we have seen that when the degree of a polynomial is 2, then we call it a quadratic polynomial, right? So to make it an equation, what we do is we equate the quadratic polynomial with 0, right? When the quadratic polynomial is equated with 0, it is called quadratic equation, right? So what was the standard form of a quadratic polynomial? Quadratic polynomial was something like this: f of x is equal to ax square plus bx plus c, right? This is still not the complete quadratic polynomial until and unless I say that a is not equal to 0, right? It would not mean a quadratic polynomial. Now I have written a is not equal to 0. Also a, b and c belong to real numbers. So now this is a quadratic polynomial that we have seen in previous lecture. So now we will talk about quadratic equation. If I equate this, let's say equal to 0, now this is a quadratic equation, right? In quadratic polynomials, we had zeros of a polynomial, right? How many zeros were there in a quadratic polynomial? There were maximum 2 zeros in a quadratic polynomial, right? And what will happen in quadratic equation? We will call these as roots of a quadratic equation. Roots of a quadratic equation. What are roots? Roots are just same as zeros. Zeros were in case of quadratic polynomials. Zeros of a polynomial were the place where were the such values of x where the polynomial becomes 0, right? In quadratic equation, the quadratic equation when equated to 0 will give us 2 such values where it is true, right? And those 2 values will be known as roots of a quadratic equation, right? So first of all, learn the standard form of a quadratic equation. Standard form is ax square plus bx plus c equal to 0, where a is not equal to 0, right? We write the powers of x in descending form. Okay, we could have also written in ascending form, but generally we write it in descending form. This is the standard form, right? Where a, b, c are coefficients and these are real numbers, and a cannot be equal to 0. What will happen if a becomes 0? It will no longer be a quadratic equation. It will become a linear equation, right? And b and c can be 0, right? For example, if let's say b is 0, then I will have a quadratic equation of the type this. This is still a quadratic equation. Why? Because power of x is still 2. Maximum power of a variable in this equation is 2, right? If even c becomes 0, even then it is a quadratic equation, right? But a cannot be equal to 0. So this is about the standard form of a quadratic equation. So now if let's say something like this is written, is this a quadratic equation or not? Yes, it is a quadratic equation because the maximum power of the variable is 2. But if I write something like this, x square plus let's say 5x plus 3x cube plus 3 equals 0. Now is this a quadratic equation? No, it is not a quadratic equation because the highest power of x here is 3. Okay, so this is a cubic equation and not a quadratic equation, right? So you should be able to identify whether an equation is a quadratic equation or not by just looking at the highest power of x. And you should not get confused by equations like this. Let us say if I write 2x square plus 3x equal to, let us say I write 5x plus 2x square, right? If I write some equation like this, this is not a quadratic equation, because if I cancel these, it will just be 2x equal to 0, right, which is of the linear form and not a quadratic equation. So sometimes you may be given some of the equation which look like a quadratic equation, but when you take all the terms to the left hand side or right hand side, you will see that it is not a quadratic equation. So don't get confused by such questions. Okay.